Alright, the essential question for this video is how can I use a graph of a parabola with a vertex at the origin to find the function. So again, the essential question is how can I use a graph of a parabola with a vertex at the origin to find the function. The reason that we're learning this one first is because it's easier to actually find the graph if we know the vertex is at the origin. So I want you to underline this right here. These are special circumstances because the quadratics we're going to be looking at in this part all have a vertex at 0, 0. And in the next video you're going to be seeing how to find the equation or the function of a graph that has a vertex anywhere. It doesn't have to be at 0, 0. So here are the steps. I'll show these right here. Here are the steps for finding the function or the equation if all we have is the graph. So far in this unit you've been getting the function and you make a table and then you graph it. Now we're going to give you a graph and say, you know what, you can use the graph to actually find the function or the equation of the parabola. Okay, so the first thing you do is you start with function form. Number 2, you replace f and f of x with the known point. Put a little note here just to remind yourself this f of x is really just y. Actually, it's not put an underline. Let's just put an arrow here. This is actually just y. So replace x and y with a known point. And then when it says evaluate x squared, you got to figure out what x is. And we're going to remind ourselves that to find what x is, if you have x squared, you just square root it, and that will give you the value of x. And then divide both sides by the coefficient of a, whatever the a value is, and then write the final function. This sounds kind of complicated as we go through the steps, but I'll show you as you practice it. It's not that difficult to do. A lot of students will choke on this because they go, oh, this looks so hard, but really just follow the steps. It's pretty straightforward. So let's take a look at an example of this, and I'm going to need to move this over. Hang on one second here. Give me one moment to change the properties of this file. And this will help me to actually be able to get everything lined up. Alright, here we go. So here's our example. We're given this parabola. You can see that we know the vertex is actually at 0, 0. And we know one point on the parabola. That's the only point they give us, is we know that the point 2, 2 is on the parabola. That's going to be, in our instructions it says, replace x and f of x with a known point. Here's our known point. Alright, let's go through our steps then. Step number 1, start with function form. Alright, so we'll do that. Let's go ahead and write our function form, which is f of x is equal to a times x squared. Now notice we're not writing ax squared plus bx plus c. The reason why is when the vertex is at 0, 0, b and c are 0. We don't use those. So that's why these are a little bit easier to solve. And we know here because the vertex is at 0, 0, again, let's just kind of go through this. If this was vertex form, we know that h equals 0 and k equals 0. Because our vertex is at 0, 0, so we don't have to worry about b or c or h or k. All we got to care about is a. And actually, to find this equation or function of this parabola, class, all you got to do is figure out what a is. Once you find a, you've got your problem solved. Alright, the next step says replace x and f of x with the known point. We'll take a look here. Our known point, we know this is a coordinate. That means the 2 is x and the second 2 is y. And since we know that here's our x value here, we're going to go ahead and replace that with the x value of our known point. And since the y value of our known point is 2, that's going to go here. So far, so good. All we've done is taken our known point, labeled it x and y, plugged it in for x, and plugged it in for f of x, which is y, and now we have an equation. The next step says evaluate x squared. Alright, well, here's x squared. X squared is 2 squared. That means we're going to change that to 2 equals a times 4. Now, usually when you write that mathematically, you put the 4 in front. You could have written 2 equals a 4. It means the same thing. A times 4 is the same as 4 times a, but I'm going to put the 4 in front because I know coefficients go in front of variables. The next step is divide both sides by the coefficient of a. Well, here's the coefficient that goes with a is 4. We're going to divide both sides by 4. And when we do that, we've got 2 over 4 is equal to a, because this 4 cancels and this 4 cancels because 4 over 4 is 1. And we're going to wrap this up. So a is equal to 2 over 4. We can simplify that to 1/2. So there is our value of a. And now that you found a, you can now take your quadratic form, your function form, and just replace the a with that value. So I'm going to write our final equation is f of x is equal to a, which is 1/2 of x squared. Now notice, I put the x back in where it's supposed to go. That's our variable. And I put f of x back where it's supposed to go. We never replace these two in our final function. Because remember, a function is just an equation that tells us if you plug in this x, out comes the proper y value. So here is our final function. This function represents this parabola. If you were to make a table now with a whole bunch of x values and y values and plotted them, you would actually get this graph. Let's take a look at one more. And I encourage you always, class, when I have 2 examples, do the next example on your own and see if it matches up with my answer. Alright, so let's go through all of our steps. Step number 1, start with a function form. F of x equals a times x squared. Again, we know the vertex is at 0, 0, therefore there is no b value or no c value. And there's no h value and no k value, same thing. All we got to do is write the a term. Alright, replace the x and y with the known point. Well, our known point is -2, -8. That's our x value, that's our y value. So our our y value is -8 times equals a times our x value, which is -2 squared. Remember, always plug in your variables in parentheses. Now class, it's very common for students to make a mistake and put the -2 here and the -8 here. Remember, the y value is f of x, and the x value is the variable that's in the equation. Alright, let's evaluate x squared. So -8 is equal to -2 squared. Some of you might write -4. Let's make sure you recognize that is not correct. If we put a parentheses and put -2 and we square that, you will get +4, because -2 times -2 is +4. So this is going to be 4a. Let's divide both sides by the coefficient on a. And that means -8 over 4 is equal to a. So a is equal to -8 over 4. And you take -8 and divide it by 4, you're going to get -2. For those of you who struggle with that part of math, just put it in your calculator. -8 divided by 4. Oops, I missed the negative. -8 divided by 4 equals -2. So our a value is -2. Let's write our final function. F of x is equal to, our a value is -2, and then we just put the variable x back in there. And you can see through this process, all we did was we just used the known point on our parabola to find the value of a. And then once we have the value of a, we know the equation of this parabola. Alright, last thing, got about 5 minutes to go. I'll talk you through this. I've already got these pre-written. Let me talk you through this. This is the kind of question you need to be familiar with. And the reason is because you need to be able to take a look at the graph of a parabola and figure out what the different points on the graph tell you. You did a little bit of this in Integrated Math 1. Here's our question. A ball is dropped from a rooftop. The graph below shows how far the ball falls over time. How far the ball falls over time. Explain what the following parts tell you about the ball. So let's take a look at our graph. Well, we've got time on the x-axis. We've got change in height, and this is meters on the y-axis. You can see the way they graphed it. Our ball started at 0, 0. That means time 0, and it's fallen 0 meters. And as they drop the ball, as time goes by, the ball falls farther and farther and farther. Notice they're representing a falling ball in terms of negative numbers, because this is our x-axis here. Farther and farther and farther until, boom, it's done. It stops. It's no longer falling. So what can we learn from this graph? Here's the first thing. If a question asks you, what does the vertex tell you? In this case, the vertex tells you the ball dropped 0 meters in 0 seconds. It is the maximum height of the ball. Notice that every point from this point forward is lower than the current dropping point. So the vertex just tells you the ball is at 0 meters, has fallen 0 meters at time 0. What does the end point mean? The end point is this point right here. What does the end point tell you? Well, think about it. The ball drops and then it stops dropping. So that must be where it hits something or hits the ground. So my explanation is the ball fell, look at 9 meters. It's gone -9. That means it's dropped 9 meters. It's fallen 9 meters. And it hit the ground in 1.6 seconds. Remember, the x value is on the x-axis. That's time in seconds. The y value is how far the ball has dropped. So this tells you a lot. It tells you the ball actually only fell 9 meters, and it tells you that it took about 1.5 seconds. It took 1.6 seconds to actually hit the bottom. The reason the parabola ends is because the ball doesn't drop any further after this. That's why it's called an end point. And the last thing is, what does the point 1.25 comma -5 tells you? It tells you that in 1.25 seconds, the ball dropped 5 meters. So the ball fell 5 meters in 1.25 seconds. So all this data is actually given to us based on how the graph is drawn and how the x and the y axis are labeled. You need to be familiar with, and you'll see some of these questions in your textbook, taking a graph and then it's going to ask you questions about what does the y-intercept tell you, what's the x-intercept tell you, what's the endpoint tell you. You need to be able to write in sentences what those parts of the graph actually tell you about what's going on in the story given by the word problem.